Hi, this is Bob at airdensityonline.com. We're going to demonstrate the addition of nitro to a blown methanol racing engine. This is our ProCalc calculator, and we already have two baseline profiles in here. One is for a methanol engine that we've been running, and the other one is for a 20% nitro engine that we've been running. What's significant here is that we found that we need about a 2.8 to 1 air-to-fuel ratio for the 20% nitro. And this is our high compression methanol engine, which needs about a 3.4 to 1 air-to-fuel ratio. So it's considerably less amount of fuel, and in this case there's considerably more fuel. What we're going to do is set up a third profile, and it's going to be a blown methanol setup, but we're going to select a low compression combination since we're adding nitro. Okay, we're creating a baseline profile from our pre-selected list. What's the significance here is the low compression engine on methanol has a less rich air-to-fuel ratio than the high compression engine on methanol. What we want to do now is take this engine combination and convert it over to 20% nitro. FYI, examining this combination involves two nozzles, both hat nozzles and port nozzles. We're going to examine doing this with just hat nozzles only in our methanol combination. Now this is an underdriven large blower, and about a 12.5 gallon a minute fuel pump, and this involves a 130 for the main bypass, and this has a 40 thousandths in the high-speed bypass. That's explained in our publications. And then these are the nozzle combinations. This starts out with smaller nozzles in the rear, and then it goes to progressively larger nozzles, and this would be applicable to a standard opening blower to get more fuel towards the front of the blower. Now, to find out what it takes to add 20% to this combination, we're going to go to the jetting calculator, and that comes up with three different alternatives. One is a main bypass calculator, the second one is an engine nozzles calculator, and the third one is jetting from pressure. We're going to select jetting from pressure, and that brings up this entry screen, and this is our combination from the baseline profile for a low compression methanol engine. Here's our approximately 3.8 air-to-fuel ratio, and that fuel system ran at about 134 psi. That would be an 8,000 RPM pressure value. To run on 20% nitro, and we'll go ahead and add 20%, and we're going to do this nitro addition by weight. This is significant because by volume 20% nitro, by weight is about 28 or 29% by volume, and it's a different amount. We're going to stick with 20% by weight, using specific gravity to get the percentage in the mixture. And we're going to come down here, and we want to make this engine richer, so we're going to go to a 2.8 air-to-fuel ratio. We're going to keep our fuel pressure the same and everything else in the setup the same. And the calculator has determined that if we change nozzles from the previous ones varying from 46 to 52, change them up to 55 thousandths nozzles, and the previous main bypass was 130, and now that would be a 108. That'll give us a 2.8 to 1 air-to-fuel ratio with 20% nitro. Okay, if you want more information about nitro, we have publications at racecarbook.com. Thank you.